Hello everyone. The title of this video is Convert between Exponential and Logarithmic Form. Each exercise I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 10.3 that's titled Evaluate and Graph Logarithmic Functions, and I'm under the heading Convert between Exponential and Logarithmic Form. Now I'm only going to be working on the even numbered exercises, right, the ones that don't have a link to a solution. Right, the odd ones have links to a solution, so I'm not going to be doing those. Alright, so starting with number 126, then 128, 130, 132, and so on, all the way until 152. I will also have timestamps for these examples in the description of the video below. Example 1's timestamp will be when number 126 starts, example 2 for number 128, example 3 for number 130, and so on. I also request that whenever I start a new question in the video, pause it and try to work it out yourself first before watching me do it and then compare. Because if you're just watching me do these questions without practicing yourself, chances are you're not learning all that much. Alright, so in this first set of exercises, we're asked to convert from exponential to logarithmic form. I got number 126 as example 1, and I have these written out. Alright, example 1, number 126, convert from exponential to logarithmic form. Well, first let me talk about these forms. Right. Off to the side here. Now a statement, an equation, is in exponential form if it looks like the following. You know, you have some base b to a power, I'll use p for power, why not? B to the p equal to some number, and I'll use n for number. Right? So this is exponential form, right? So you have a base, right? And the base for all these problems is going to be a positive number, right? For every single problem we're going to deal with, the base will be a positive number. Then you have a power, or an exponent, right? Thus the name exponential form. Power, right? Exponent, same thing. And then on the other side is just a number. And what we're going to see eventually, too, throughout our discussion of exponents and logarithms, is that this number will be will be positive. All right, it'll be a positive number, but I'm just going to write number right now. Now, logarithmic form. In order to convert from exponential form to logarithmic form, you have to know the following. Alright, I'm going to make this little note down here, a little star next to it. Logarithms are exponents. Just a fancy word for exponents. Okay, and then the notation for a logarithm is the following. You have some notation here for a logarithm. You'll see this log, short for logarithm. Very often I'll just say log. And then there's going to be a tiny number, a subscript, which I'm going to call lowercase b. This is the base of the logarithm. And then it's like a function where after the name of the function log base b, you have an input. So say log base b of some number n. Right? So again, this little b here is called the base of the logarithm, and once again it's going to be positive. You got just some number, and what this is going to be equal to, right, as I said here, logarithms are exponents. So the log base b of n is the exponent, the power. The exponent you would have to raise b to get n. The exponent you would have to raise little b to, right, the base b here to get the number inside. Right. So this is important. Right? This is the meaning of a logarithm. All right, so before I get back to logarithmic form, let me show you some examples of simple logarithms. So for example, the log base 2, right, log base 2 of 8, say, when you see this, the logarithm base 2 of 8, or log base 2 of 8, equals an exponent. And the number over here is the power you would need to raise 2 to get 8, and that's 3. Right, and this is because, right, this is since 2 to the 3 power equals 8, right? And it kind of flows like that. The little number base, this base raised to this number power equals the number inside the logarithm. Base to power equals input. This input is also referred to as the argument of the logarithm, but I'm not going to write that out. Right? All right, so one further example here, and then we'll get back to logarithmic form, which I kind of gave you an idea of here, how to go from exponential form to logarithmic form. Another example, what's the log with a base of 3? Log base 3 of 9. All right, the log base 3 of 9, again, is just an exponent. Logs equal exponents. Logs are exponents. So what exponent would I need to raise the base of 3 to get 9? And that would be 2, right? Since 3 squared, right? Again, it's base raised to this number on the other side will equal the input of the log. Pardon me, that says equals. So 3 to the second equals 9. And what I'm doing here is showing you how to change from logarithmic form to exponential form very easily. You take the base of the log, raise it to the other side, the number on the other side, which will be the exponent, right? What logs are equal to are exponents, and that'll equal the number inside the logarithm. And then you just kind of reverse that to change from exponential form to logarithmic form. Right? But hopefully it makes sense now, a little bit. what logarithms are. So if I'm switching, back and forth between exponential form and logarithmic form, right, so I'm starting here and I say let's change it to an equivalent logarithmic form. So if b to the p is equal to n, that means that the log base b, right, the base here in the exponential form is the same as the base of the logarithm. The log base b of the number, right, of the number on the other side of the exponent of n is equal to the power, is equal to the exponent. And that's what I've been saying right here. Logarithms are exponents. The logarithm should be equal to a number that was a power in exponential form. All right, I'll say that one more time. The logarithm should be equal to a number that was an exponent, back in exponential form. Right? And you should be able to go back and forth between these. If b to the p equals n, that means p equals the log base b of n. Right? And again, the base on the log is the same as the base on the exponent because, again, logs are exponents. Can't say that enough. And if you see logarithmic form, I already showed you how to change to exponential form. You take this base, raise it to the power on the other side, right? The exponent that the log is equal to, logs are exponents, and it'll be equal to the number inside the log. All right, and this is big. All right, and this is what we're going to be doing for the entirety of this video. Changing back and forth between exponential form and logarithmic form. Alright, so a pretty swift example to start with. Number 1, right, exercise 126 from the text. This is in exponential form. Right, we have 4 to the second power equals 16. So that's here. So base is 4. So in logarithmic form, I'll have log, the base of 4 is going to be the base on the logarithm, like the little subscript of some number equals, and remember the number the log is equal to is the exponent on that base. So this is 4 to the second, 4 to the 2. So the log base 4 of some number will be equal to 2. Right? Again, the exponent is what the log is equal to. Logarithms are exponents. Exponents are logarithms. And like I said earlier, I can't say that enough. Get that through your heads. Right? And then obviously the only other number left is the number on the other side of exponential form here, 16. That goes inside the logarithm. So these mean the same thing. These are equivalent statements. Right? They say the same things. Right? Saying 4 to the second power is 16, right, is exactly the same thing as saying that the log base 4 of 16 is 2. Right? Because remember I said down here, right, when you see the log, right, the log base 4 of 16 is what's the power that I need to raise a base of 4 to get 16, and that would be 4 squared, right? So this is going to be equal to 2. And I'm going to put that in a box, right? That's our answer. This is the logarithmic form. All right, great. Next question. Same stuff. So here we have exponential form. 3 to the third power equals 27. And I write an equivalent statement to that in logarithmic form. So again, the base on this exponent is 3, so that's going to be the base on the logarithm. Right? So the log base 3 of some number is equal to the exponent, right? The exponent is equal to the log. So 3 again over here. And the number on the other side, 27, goes inside the log, right? And again, make sure it makes sense. The log base 3 of 27 is 3, means that the power I need to raise 3 to get 27 is 3, and that's clear. 3 to the third is 27. And that's it. Very swift, very easy once you get the hang of it. Alright, so again, I'll keep doing this. Alright, question 3, same stuff. Right? We're given an equation in exponential form. 10 to the third power equals 1,000. So you have a base 10, exponent 3, and equals, some number, 1,000. So the log base 10, right, that was the base on the power, of 1,000, right, the number on the other side, equals 3, right, since 10 to the third power does give us 1,000, right? And there you go. Now, interesting thing about log base 10. Sometimes log base 10 is just written log with no base. This is sometimes referred to as the common logarithm, right? Because base 10 is a common base. Every number we work with in daily life, in most cases, is base 10, right? Decimal. So this is referred to as the common logarithm, the common log. So another way I could have written this, right? Another way I could have written that was log of 1,000 equals 3. Right? This is just as valid as what I wrote with the log base 10. Right? And you'll see this very often on calculators. Alright, let me show you with my, I have a TI-84 simulator here, emulator. You may notice that there's a button on the left side that just says LOG. LOG like that. That's log with a base of 10. Right, so if I put 1,000 in here, right, and say hit enter, it should give me 3 back, right, since 10 to the third power is 1,000. Right, and you can test it with other things. The log of 100 should be 2, since 10 to the 2 is 100, and so on. But that LOG button on most calculators is base 10, log base 10. Okay? Alright, so let's get rid of this and move on. Alright, next question. Alright, number 4, same stuff, but with some variables involved. But all they're asking me to do is change form. Change form. So we have a base of x, an exponent of 1/2 equal to some number, right? Some positive number, the square root of 3. So another way of saying this, an equivalent way of saying this, is log base x, right? That was the base on this exponent, of the number on the other side, right, of the square root of 3, equals the exponent on this base, 1/2. Right, again, I'll say it almost every time. The logarithm should be equal to an exponent. Right? And the exponent up here was 1/2. Right? So what you had the log should be equal to that 1/2. Right? Logs are exponents. Okay, wonderful. Next question. So 32 to the x power equals the fourth root of 32. Again, we're not asked to solve for anything, we're just asked to change forms. So right now it's an exponential form. I write it in the equivalent logarithmic form. So this is logarithm, the log base 32, right, that was the base on this exponent, of the number on the other side. Right, the fourth root of 32 is the input of the log, equals x, right, the exponent. Logs equal exponents. And that's all. Now eventually we'll see stuff like this and actually solve for x. But for right now, we're only asked to change forms. Right, question 6, exercise 136, same thing. Got a base to an exponent equals a number. So an equivalent statement in logarithmic form is the log with that base, log base 1/4 of the number of 1/16 equals the exponent. Logs equal exponents. Right? And checking it out, 1/4 to the second power is 1/16, right? So that's a proper log form there that is equivalent to the exponential statement. All right, just got a couple more of these. Very simple once you get through a few of them, right? 3 to the -2 power equals 1/9. Right, the equivalent logarithmic statement would be the log base 3 of 1/9 equals the exponent on that base of 3. The exponent was -2, right? And once again, I'll say it. Logs equal exponents. Logarithms are exponents. And if you want to check, again, just see 3, the base 3, 3 to the -2 would be 1/9. Now, question 8, this is the last of these, where we're asked to change from exponential form to logarithmic form. Alright, so again, I have a base e. Remember, e is that 2.718. Alright, it's about 2.7. That's called the natural base. We have e to the x power equals 6. Alright, so the equivalent logarithmic form of this statement would be the log base e, right, that was the base on this exponent, of the number of 6 equals the exponent, which was x. Logs equal exponents. All right, now this is not incorrect. Right? This is totally fine to write this way. But just like with the log base 10, right, remember how log base 10 is sometimes written as just log, right? I pointed that out, the common logarithm. Well, just like that, sometimes in some texts, when you see log base e, it's going to be written in a different way. Instead of log base e, it's going to be written as ln. This log base e, or ln, this is called the natural logarithm, right? E was called the natural base. So it's only natural that this would be called the natural logarithm. Okay, so another way I could have written this, instead of log base e of 6 equals x, I could have written, ln, the logarithm natural, logarithmic natural, right? Some French stuff. I apologize to French speakers out there, that was probably terrible. Ln of 6 equals x, this means exactly the same stuff. Right? This is totally valid. And also, on a calculator, most calculators, you will see this ln show up. Let me pull that TI-84 back up. You see right below the log base 10 button, log, there's an ln button. See, ln. That's log base e, right? So like the natural log of e, this should be 1, right? Because e to the 1 is e, right? Or the natural log of e to the third power, right? This should be 3, right? Since e to the 3 equals e to the 3, right? And so on, right? But yeah, so this is log base e, this ln button, right? Yeah, and you'll see that on most calculators. But yeah, writing it as log with a little base e isn't wrong though. All right, please understand that. You know, these are both the same. Okay, now for the remaining problems, we're going the other way. We're going to be given a statement in logarithmic form and asked to go back to exponential form, write an equivalent statement. So yeah, so convert each logarithmic equation to exponential form. And remember, I told you how this is done. I kind of pointed it out earlier. Remember, this is the base. Right, so here I have 3 equals the log base 4 of 64. So the base is 4, and what the log is equal to is the exponent. And that's really all you need to know to be able to change it to exponential form pretty quickly. Right? This would be base 4 raised to the exponent 3 equals, you know, the number inside the log equals 64. And this is true, right? 4 to the third power equals 64. Right? And these are equivalent statements. They say the same thing, but just look different. There we go. That is exponential form when we were given log form. Easy, easy, in my opinion. All right, so question 10, number 144 from the text. We have 4 equals the logarithm base x of 81. So remember, the base is x, and what the log is equal to is the exponent. So this is x to the 4th power equals, and then the number, the expression inside the logarithm equals 81. And that's all. That is all we're doing. I guess I should put that double arrow again, right, to let you know that these are equivalent statements. They say the same thing, but look different. That's all. Alright, question 11. 0 equals the log base 12 of 1. Again, the base is 12, and what the log is equal to is the exponent. Right, so 12 to the 0 power equals that expression inside the log equals 1. And these say the same thing. And this is true, right? You've seen this kind of stuff before. You know, 12 to the 0 power. Any non-zero number to the 0 power is 1. Right here, 1 equals log base 3 of 3, right? 3 base, the log is equal to 1, 1's the exponent, and 3 to the first is definitely equal to the number inside the log, 3, right? 3 to the first equals 3. Definitely a true statement here. And again, this statement in exponential form says the same exact thing as this statement in logarithmic form. I got just 2 more of these. Again, very basic stuff. All right, once again, you know, here in number 13, I'm saying -4 equals the log base 10 of 1/10,000th. As I was saying earlier, you know, you could also, they might also write it this way. negative 4 equals the log, just log, with no base, of 1/10,000th. These mean the same thing, right? So if there's no base, you're assuming here in this text that it's base 10. All right, so changing this to exponential form, right? The base is 10. What the log is equal to is the exponent, right? 10 to the negative 4th power equals the argument of the log, the input of the log, 1/10,000th. And that's it, right? That is a true statement as well. Right? All right, and the final question, again, very similar to the previous one, where we have a logarithm that could be written in a different way. Here we have 5 equals the log base e of x, the natural log. This could also be written this way. 5 equals, the ln of x. These mean the same thing. But when I change this to exponential form, right, the base is e to the 5th power, right, what the log is equal to is the exponent. E to the 5th equals the argument of the log, the input of the log, the expression inside the log, x. E to the 5th equals x. And that's it. All right. So yeah, so the key is to remember the forms, right? And how easy it is to transfer back. You should be able to easily transfer back and forth between these. Right. And I'm hoping that watching me go through these 14 examples here helps you in some way, when you're asked to convert between exponential form and logarithmic form on your own. And thank you very much for watching.